Hey guys, it's Danny here, and today during my computer science club we talked about dynamic programming and some of the concepts behind it, so I thought I'd just kind of make a video talking about how I approach dynamic programming problems and a common way you might see it and just the general idea behind it. And so for this, I'm gonna be walking us through this problem, Leetcode number 70, climbing stairs. But before we get into that, I want to talk about what dynamic programming is. And dynamic programming is a way of breaking down a problem into smaller subproblems to calculate an answer based on these previous subproblems. And so a lot of the times what this would look like is something like this. And it would look something like comparing values from each array. Like you'll make an array and then you'll calculate the smallest possible subproblem, and let's say you number like 1, and then you'll find the next, which is 2, and then maybe you multiply them and you keep doing that, and maybe that gets you your answer. But the idea is that you're breaking it down into these little subproblems and then comparing previous results to get the next solution. And it's kind of vague, but I think you'll see what I'm talking about once I get into this first problem, which is called climbing stairs. So the problem goes as such. You are climbing a staircase. It takes n steps to reach the top. Each time you can climb either 1 or 2 steps. And how many distinct ways can you climb to the top? And so to visualize this, the first thing I recommend is visualizing the problem. So first we're going to visualize stairs. We have stairs going out like this, all the way up, and that's n total stairs. And this will be like the first stair, second stair, third stair, fourth stair, fifth stair, and that's the nth stair right there. And now what this is this is just a visualization of the problem. This is what it looks like. We have our steps, we're numbered, and we can see all of our steps. And now each time you can climb either 1 or 2 steps. So that means if I'm here, I can either go 1 or I can go 1, 2, which means from this step I can get to these 2 steps, and so on. So if I get here, then I can go 1, I can keep going 1, or I can go 2, and that's kind of how the problem works. And so the first thing we're going to do is we're going to break down the problem. We're going to see the smallest possible way to view the problem. So what is n when n is the smallest? So let's say n was 1. Let's say we had 1 stair. Let's think about how many ways are there using 1 and 2 step combinations. How many ways are there to reach this value of 1? And the answer to that is just going to be 1. There's only one way to reach the first step, and that's by taking 1 step once. Now, for the second step, let's think about how many ways there are to reach this. So the first way we would reach this is by taking 1 step onto it. Now, if we took 1 step onto this, it would be coming from the first step. And so we'd go to the first step to the second step, which means however many ways we can get to the first step, all we have to do is add 1 to get to the second step. So that means all the solutions from this step can be added onto this. And now to address the second part, what if we took 2 steps onto it from the ground? So that would be 1, 2. And that would be only one way there, because there's no ways to get to the ground. So there's only one way to get here using that. So the answer is, for the second step, there's 2 ways to get here. You can go 1, 2, or just 1 from this step. Now, this is where the dynamic programming comes in a little bit more into play. Now, at the third step, now that we have these subproblems for the steps before, we need to think, how many ways are there to reach this third step? And the answer to that is by climbing 1 step onto it or by climbing 2 steps onto it. And now we can look back at these earlier solutions. So how many ways are there to reach this second step? There's 2 ways to reach it. And this goes back further and further. And so because we know there's 2 ways to reach this second step, we know we can just add this onto here. All we need to do is just jump 1. So all the ways you can reach here, every single combination of things, all we do is add 1 to the end, and we can get this value of 3. Now, for the first, that's if we're taking 1 step. Now let's assume we're taking 2 steps. That would mean that we're coming from this 1. And so now we need to think of all the possible ways to make it to this 1. All we have to do is add 2 to make it to 3. So we can simply combine these 2 numbers to get 3 for this spot. Now, the fourth step is where it's going to ramp up once again. Here, if we can erase. Oh, this is going to be clanky. Good enough. So now to get to this fourth step, we need to think, how many ways did we get here? The decision that would need to be made to get here is either one step or one step to get here. How many ways are there to get to the step ahead? So this means we have many combinations to get to this third step, and all we do is we add 1 to the end to get here. So for example, you could have 1 plus 1 plus 1 plus 1 to get to this third step, or 1 plus 2, or 2 plus 1 to get here. And that all equals 3. But now all we need to do is we add 1 to the end of any of these. And that's how we would get to this fourth. So anything from here, we can just add that onto here. So that's 3. And that's for the first step if we were to add 1. Now, what if we were to add, say 2 steps, like this in this problem? If we were to jump 2, nope, we would be coming from here. We would be going 1, 2. And that would be however many ways we can reach here, just plus a 2 at the end. So we could have a 1 and a 1 to reach there, or a 2 to reach there. And those are the ways to reach that step. And now if we were to simply add a 2 to that, that's how we get our number 4. We add this second step. We calculate all the possible ways to reach here for the smaller problems and then combine them together. And so that means each one of these solutions is a valid way to get this, and same with the ones we calculated for these. And all we have to do is we just add them together to get a value of 5 here. And now hopefully you can kind of start seeing a pattern. If not, you can just continue the method I talked about. You can see, look at all the possible ways for the steps before, and then just add a 1, and look at all the possible ways for the step 2 ahead, 2 before, and just add a 2 to that. Kind of like what we're doing here. I think this is going to be the best way to visualize it, and I'll add back the other ones for you guys. 1 plus 1 plus 1, 1 plus 2. And all we need to do for this one, we're just adding the 1. And that's coming from this step. This one's coming from this step. And that's how we would get to this fifth thing, by combining the 2. That's how we got the number 5, is a mix of those 2. So now that we have the idea, we understand how we'd calculate each individual step, all we need to do is turn this into code. And this is where a lot of people can get tricked out, because there's many different ways to approach this. In class today, people most notably tried using a recursive approach, which can work, and there's many ways to do this, but the most straightforward I've seen is to use an array for this. You can store all these values into a one-dimensional array, and then just find whatever n is. You can find the nth value in that array to find it. And so let's start coding. So the first thing we're going to do is we need to make a way to store each one of these values. And so there's going to be 1, 2, 3, 4, 5, up to n values. So we're going to make an int array. Oh, my array was new. An int array of length n. And now this will allow us to store n values in it, which means we can calculate each individual one up into it. And we need to populate this array. We need to add these values into the array on our own in order to find the answer. So we're going to have a for loop going through it. And now I'm coding this in real time too, so I'll do bug fixing as well. But you have the array, and so now we're going to start the very first thing. The very first thing, where is it? Right here. On the ground level is 0. We have no ways to get there. But at the first, we have 1, which it can be a little bit tricky to add to account for things that might be, I guess, like the very early steps of it. So the way I would like to approach this is I would just initially populate the array. I would say my array at 0, and this is going to be, this is really index 1. This is step 1. So step 1 has one way to get there. And so we're just going to populate that right now. And then step 2 has 2 steps. This is step 2. 2 ways to get there. 1 way to get there. And now that we have these 2, we can start at this second index that we haven't initialized yet. And we know how to calculate this now. We know how to look at the 2 before it and simply add them together. And because we started it here, we actually don't have to account for indexes being out of bounds, because just of the way the for loop works, we have I equals 2, and we're never going to go below 0. So my array at I. So right now I'm thinking at 2, how am I going to calculate 2? When I is 2, so the second value, we're looking at, it's a 0 indexed array, so this should be 0, 1, 2, 3, 4. I'm looking at index 2. How did I calculate this? Okay, so I looked at 2 and 1, and I just added these two values together. So I added the first index and the 0 index together to make this. So that's just I minus 1 and I minus 2. And so now equals I equals my array at I minus 1 plus my array at I minus 2. And so this is just the basic, this is how we're going to populate the array. So this works for the first one. And now we're going to, now that we have part of a solution, we're going to look and we're going to see what do we need for the next index. So the next index, let's say it's 4. So now we have our array. I'm going to kind of visualize it here. We had our original 1 in the 0 index, 2 in the first index. And now to calculate the second index, let's look at what our math did. We did my array at I, which is 2, equals the minus 1 plus the minus 2. So it's these two values, and that's how we got 3 here. And now the next value is just the same thing. And this is just the overall approach to the problem. And now you may be asking, now that we have this array, how are we going to find the answer? And the answer to that would be we're going to find wherever index n is, that's what we're returning. And because we only set it to n, it's actually going to be the last thing in the array. So we're going to return my array at n.length minus 1. And this will return us the last element in the array, which is also the last element that we dynamically programmed. And if we run our code, don't make me look like an idiot. Oh. So actually, n.length minus 1 doesn't work. That's because n is not a length, n is an int. So we could do n minus 1, or we could do more appropriately in what will be more universal, we do n my array.length. The length of the array minus 1, that's the last index of the array. That's something you know from CSA. And we've accepted. And once we submit, index out of bounds. So we ran into a solution, index 1 out of bounds for length 0. And this is just what kind of happens. I tried to shortcut a little bit. One way you could work around this is we could add in the if statements. We could say if I minus 1 is greater than 0, if I minus 2 greater than 0, we could do all that. But instead, I think what we're just going to do is we're just going to say if n, is this there? Hey, wait. Equal to 1, return 1. N is 1, just return 1. I'm going to spitball in here. Oh, there we go. Okay, so this is a very choppy way to do it, but this is the most straightforward, but use the memory complexity isn't the best, and I think that's resulting from this potentially. The runtime is good, which is kind of overall what you really want to strive for, because if your complexity is too large, or if you're not in the proper big O of n, then your program will just kind of blow up in your face. But yeah, so once again, to review the dynamic programming concepts that we talked about, dynamic programming is the idea of scaling down a problem to its smaller parts, and then using those solutions to the smaller ones to solve the bigger ones. So we found at step index, for all these indexes, at step 0, there's one way there, 2. And then we use these 2 initial values to calculate everything else, because we knew in order to get to this one, in order to get to this thing, it would be all the combinations for index 1, which is 1 plus 1, and 2, and all we have to do is just add on that extra 1 at the end to get these. And so it's all these combinations plus a 1 at the end. And same thing goes for this. We just had a 1 plus a 1. And that's how we got the first one. Then we combine all these, and that's how we got the 3. And now, this is a somewhat straightforward approach, but I was also asked in class, how would you identify something like this? And the one way you identify something like this is you would see how many distinct ways can you climb to the top. I guess visualizing the problem, when you first visualize it, just writing it down, we have stairs. We're incrementing up and up and up, and we can see how many steps here. just by breaking every problem, you should honestly break down to smaller parts and then expand. And when you break this one down, you can see that actually the solutions are somewhat linear, and you need to in order to calculate each one, you need answers to the one before it, which can also look very recursive. So there is recursive solutions to this. Let's see. This one has good complexity. This is the recursive approach. Looks somewhat simpler, but coming up on this on your own is going to be a bit tricky, especially if you don't have much experience with it. And then I think this memoization, I'm not sure what that is. So this is the dynamic programming array. I think this is similar to what I have. This first statement is exactly what we have, and then it initializes an array, and then this is just the basic same solution as our code, except mine is somewhat readable. So yeah, I hope you learned something today, and I'm gonna have another video coming out on a problem like unique paths and talking through how I personally would solve it. See ya.